Hello everyone. Today we have the second lesson on the particular nature of matter, and in today's lesson we are going to see the three main objectives we will cover. One is evidences for kinetic theory of matter. Second is heating and cooling curve, that's a graph. And finally diffusion, that's a big area and you get a lot of questions in IGCSE exams. Both core and extended paper, you get a lot of questions from diffusion. And in red, that's for only extended curriculum, you need to know the Brownian movement or Brownian motion, its evidence, diffusion rate and molecular mass. We will discuss that. That's what today we are going to discuss. Evidences for kinetic theory. Kinetic theory means the particles are moving, whether it is solid, liquids or gases. The particles are on continuous movement. How do we explain that? Solid we have less evidences, the movement is only vibration. The liquids you can easily prove, and in gases also you can prove. Liquids, I can tell you an example. You take any color, maybe a drop of ink on top of water, you just add a drop of ink into water and you will see the ink is spreading. And also potassium manganate, as a chemist you would like to see some colored substances. KMnO4 or potassium permanganate is the best. And you can watch the videos, or I will have the videos added to this. Potassium permanganate, when added to the solid potassium permanganate, when added to water, you can see the pink streaks going down. That shows the movement of the pink potassium permanganate particles moving through liquid molecules, liquid water molecules. So there is space between the water molecules. That is why potassium permanganate particles can move down. That clearly shows movement of particles in liquids. Solid particles moving through the liquids. Between the gases, I can tell you an example. You take liquid bromine. Liquid bromine is it's highly poisonous, and you need to do it in fume exhaust hood. And that will be, if you are taking in a gas jar the liquid bromine and you leave it open with a covering lid on it, and you have another gas jar brought on top of that, remove the lid from between, and you see the liquid bromine evaporates, it becomes gaseous bromine or vapor of bromine, and the vapor of bromine is slowly and moving and diffusing, and it becomes uniformly brown, orange-brown color. So these are examples of kinetic theory. Next subtopic is heating and cooling curve. First you take the heating curve. For heating curve, the heating is solid. When a solid is heated, it changes to its liquid, liquid to its gas or vapor. This is on heating. It absorbs heat. Anything which absorbs heat is endothermic. So that is endothermic. You just need to know why is it absorbing heat, why solid to liquid, the change solid to liquid, which is melting, absorbing heat. Because energy is required to break some of the bond. From now on, you should be familiar to the concept that in order to break a chemical bond, we need to spend some energy. When energy is absorbed to break a chemical bond, we call it endothermic. Energy is being taken in. So it's an endothermic process, we need energy. And from liquid to gas, you know that every chemical bond, every single chemical bond is broken when a liquid molecule is converted into its vapor. So it needs to make a lot of energy as well. So energy will be absorbed for the conversion. Let us see the graph, how it will look like. Here you have temperature, here here you have time or extent of reaction. For temperature, the unit will be degrees Celsius or Kelvin. Now, it will start at a particular temperature as a solid, then it will be heated to a certain temperature, where you can see the graph becomes flat for a while, and then again the temperature increases for a while. It remains flat for another portion of the graph, then again it increases. This is the general shape of the graph of a heating curve. We have taken a solid. I'm taking it as starting A to B, then C, then D, E, and F. We have a lot of things to explain. To understand it easily, we can take example as solid ice. Okay, let's start with the solid ice. This is ice. And temperature, let us say we start from minus, this temperature was minus 25 degrees Celsius. And of course, this is the temperature where it changes, ice changes into water. And what will be the temperature? All of you know the temperature is 0 degrees Celsius. And it moves on, and until the water becomes its vapor, the temperature is 100 degrees Celsius. Here you have ice changes in the water, but it is not always water. Maybe some ice in the beginning as well. All through the temperature, there is an equilibrium between. We say it is existing together. Ice and water exist together. But water appears at the point B. Water appears at the point B, and at C, it's only water. Right? Then it moves until D, that's only water, and here appears water and steam. Basically, we said this is the area we have only ice, this is the area we have only water, and this is the area we have only steam. So, if there is a coexistence of both ice and water, that should be somewhere over here. And I know that many of you have a doubt in your mind, steam appears at any point above 0. That is true, there will be some amount of steam as well. I'm not denying that. But generally, it will be predominantly water there, and water-steam coexistence continues and in this region as well. And after that, there will be no traces of liquid water. And what do you call this point? That is boiling point, BP. And this, that is melting point. Sorry, you made a mistake. Melting point, and this is the boiling point. This shows a heating curve, and you should be able to explain so many features they can ask to explain in the examination. So, what are the ice you start with, or a solid you start with? It changes, or it keep on increasing its temperature as you give the heat in. And finally, once it reaches its melting point, it melts into its liquid. Then there is a coexistence of both equilibrium. Then later on, it's only liquid. Liquid is getting heated up to its boiling point, and at the boiling point, it starts to the conversion of the liquid to gas. It's at the highest rate, and you get boiling happening here, and then finally you have only its vapor. The process over here is, this process is melting, process happening here is melting, and the process here is boiling. And you have the differences between boiling and evaporation. Evaporation takes place at all temperatures, but boiling takes place only at one particular temperature. Okay, if this is the heating curve of a solid, what would be the cooling curve opposite of a gas or a vapor? You can try, and it will be just reverse of it. You can try it as your homework for today. And after this, we have heating and cooling curve, then you have diffusion. In diffusion, we need to